So far, we looked at optimal pricing with a two-part tariff or price quantity pairs when there was only one type of consumer. Now we're going to look at the case where there are two types of consumer. So when there's only one type of consumer, second-degree price discrimination and first-degree price discrimination are essentially the same thing. When there's more than one type of consumer, now it matters whether the monopolist can distinguish between the two types of consumers. And here we're going to look at the case where the monopolist can't distinguish between the consumers and therefore must offer them the same things. So to keep things simple, we have two types of consumers. Think of it as one consumer of each type, or there's two equal-sized groups, one of each type. So we have a low demand type L and a high demand type H. The H type demand curve is everywhere above the L type demand curve. Now these quantities are the efficient quantities, because here we're going to assume that the marginal cost is zero. And this assumption is just to make the diagrams neater. It means we don't have to draw a marginal cost curve up here and have that cluttering up the diagram. So Q0H is the efficient quantity for type H consumers, and Q0L is the efficient quantity for type L consumers. And these would be the amounts the monopolist would sell under first degree price discrimination to each type of consumer. So now let's think about which price quantity pairs maximize profit. So we'll start with the simple case, first degree price discrimination, and then we'll move on to second degree price discrimination. So we'll look at the case where the monopolist can distinguish between the two types. The two types are observable to the monopolist. Now let's think about what should the monopolist do in this case. Well, because they can distinguish between the two types, they can offer each type a different price quantity pair. So we need to think about what should they offer to L and what should they offer to H. So looking at this diagram, let's look at L first. This is their demand curve. Now we know under first degree price discrimination that the monopolist wants to sell this quantity here, because that's where the marginal cost curve crosses the marginal benefit curve. And this marginal benefit curve is also the marginal revenue curve, because the monopolist is able to charge exactly what the consumer is willing to pay. Now what price should the monopolist charge for this number of units? Well, it should charge the area under the demand curve up to that quantity, that is area A. So the monopolist must satisfy what's called a participation constraint. And all the participation constraint is that the consumer must get at least as high a consumer surplus from buying as from not buying. So the consumer surplus from not buying is zero. We need the consumer surplus from buying to be greater than or equal to zero. So we need the price for this many units to be less than or equal to what the consumer is willing to pay, which is just A. So we need the total outlay, the price in the price quantity pair, to be less than or equal to the willingness to pay, which is A. And optimally, the monopolist will choose to make that equal to A, because it wants to make the price as high as possible. So we found that the monopolist should offer L, the price quantity pair, TL, QL, where TL is equal to A, the price is equal to A, and the quantity is equal to Q0L. Now we need to do a similar thing for buyer H. The optimal amount to sell to buyer H is Q0H, and again we need to satisfy a participation constraint. The consumer surplus of consumer H has to be non-negative, so we need the price for consumer H to be less than or equal to what they're willing to pay. And what are they willing to pay? It's A plus B plus C, the area under the demand curve up to this quantity. And again, the monopolist will choose TH so that consumer H is just indifferent, so that this is actually equal to A plus B plus C. So at the optimum, both of the participation constraints hold with equality. The consumer surplus of both consumers is zero. So the optimal price quantity pair to offer consumer H is the price quantity pair where the price is A plus B plus C and the quantity is Q0H. Both consumers get zero surplus, and the profit, if we add up the two prices, Remember, there's one consumer of each type. We get 2A plus B plus C. If there's more than one consumer of each type, but the size of each group were equal, then we'd just multiply this number by the number of each type. Okay, so now let's look at the case where the two types are unobservable to the monopolist. So they can no longer distinguish between consumer L and consumer H. So now we're looking at second degree price discrimination. The monopolist has to offer them the same things. And to begin with, let's suppose that the monopolist offers the same options as it did under first degree price discrimination. So it's still offering the two options, but now both consumers get to choose which one they buy or whether they buy it all. So the menu of price quantity pairs, there are two price quantity pairs here, is this. Let's think about which of these pairs L would choose and which H would choose. Now here we have to think about which pair gives each consumer the highest consumer surplus. Let's think about L. They were getting zero consumer surplus before from buying this option. Can they get a higher consumer surplus from buying this option? Well, no, because the price here is higher and consumer L is not willing to pay anything for these units. So they would get a negative surplus from buying this option. The price, which is the area under this demand curve, is more than what they're willing to pay, which is just A. What about consumer H? So let's think about H's consumer surplus from each of the options. So H's willingness to pay for Q0L units is A plus B, the area under their demand curve up to that quantity. And H's willingness to pay for Q0H units is A plus B plus C. So H's consumer surplus from the two options, well, we know this is zero because we chose the price here so that it was exactly equal to H's willingness to pay for Q0H units. What about the other option? Well, the price here is A, the willingness to pay is A plus B. The consumer surplus is going to be B, which is bigger than zero. And so consumer H would want to buy this price quantity pair, the one meant for L. So what would happen? The monopolist is going to sell two of those price quantity pairs, and their profit is going to be 2 times A. Now, can the monopolist do better than this? Well, yes, they can. They can change the price and or the quantity and increase their profit. So let's see exactly how they can do that. So let's for now just think about changing the prices. So we're going to keep the quantities and the price quantity pairs the same and think about how can we change this price or this price in order to increase profit. Now, let's look at this one first. Can we change the price in this price quantity pair or should we change it? Well, we can't increase this price because then consumer L would not buy this option. And we don't want to reduce it because then it just makes it more attractive for consumer H and gives consumer L more consumer surplus. So we have to look at this price, the price in the second price quantity pair. And what we want to do is lower it so that buyer H prefers this option. So we need to lower it enough so that their consumer surplus from this option is more than or equal to the other option. So we need to satisfy what is called an incentive compatibility constraint. So if we look at the consumer surplus here, we calculated with these price quantity pairs, what we want to do is make this at least equal to B. Well, how can we do that? We just need to reduce the price by B in this price quantity pair. So we need to reduce it from A plus B plus C to A plus C. And then consumer H will get a consumer surplus of B. And they will be indifferent between the two options. We can assume they buy the one the monopolist wants them to buy. So this is the incentive compatibility constraint we have to worry about. We need the consumer surplus from the option we want buyer H to buy to be at least as high as the other options. That is the first price quantity pair. So just to summarize that, the monopolist can improve its profit if it keeps the first pair the same, but lowers the price for the second pair by B to give consumer H a consumer surplus equal to B, the same as from the first option. The profit now will be 2A plus C, which is better than 2A. Now, is that the best the monopolist can do? Well, no, it can actually do better. And to do better, it has to change the quantities and adjust the prices. So let's think about which quantity should it change. Well, it should change the quantity in the pair meant for L, because then that will make that pair less attractive to H, and that will enable the monopolist to actually charge a much higher price for the second pair, the pair meant for H. So the monopolist is decreasing its quantity to QL dash, and in order to keep selling that quantity to buyer L, it's going to need to lower the price by this triangle here. So let's call that triangle A. So this is A. So the monopolist is going to change the price quantity pair. It reduces TL by small a to A dash, and it's reduced the quantity to QL dash. So A dash is equal to A minus small a. So this is so far a reduction in profit of A. But that's a very tiny triangle because consumer L is not willing to pay very much for these units here. Now, what is the gain? Well, there's going to be a gain from selling to buyer H. Let's think about how should the monopolist design the pair meant for H. So we're not going to change the quantity because that would just reduce H's willingness to pay and lower the monopolist's price. So we're going to keep the quantity the same, but we're going to change the price, and we're going to be able to increase the price compared to what it was before. We're going to be able to increase it from A plus C. So what is the monopolist going to be able to charge? So let's do the same calculation we did earlier. We need to check that buyer H gets at least a higher consumer surplus from this option as the other option. So the willingness to pay of H for the first option is A dash plus B dash, the area under the demand curve, up to QL dash. So their consumer surplus from buying that quantity at A dash would be B dash. So we're going to need to give buyer H at least the consumer surplus of B dash, and in fact exactly that much if the monopolist wants to maximize profit. So what's the willingness to pay for Q0H? It's A dash plus B dash plus C dash. So we need to make the price for Q0H equal to this minus that, or A dash plus C dash. So let's see what the gain is from being able to increase the price to consumer H. So we want to compare A dash plus C dash to A plus C, which was the previous price for this many units. So to do that, we need to introduce another area on the diagram. So let's call this area small c. So we already saw that A dash is equal to A minus small a. How does C dash compare to C? Well, C used to be this triangle here. So C dash is equal to triangle C plus A plus C. So this allows us to find the increase in the price and the price quantity pair meant for H. So this is the old price, A plus C. The change, well, A and minus A cancel out. The change is just C. So C is the gain from reducing this quantity and adjusting the prices in the price quantity pairs. A is the loss. And the gain far outweighs the loss because buyer H's demand curve is much higher than buyer L's. Buyer H is willing to pay quite a lot for these units compared to buyer L, and so it makes sense to reduce the quantity here and adjust these prices. So the new profit is 2A dash plus C dash, and we can write that in terms of our A's and C's. This is the old profit, this is the gain. The gain, remember, is just that area C minus that small area A. Now, can the monopolist do better? Well, let's think about another reduction in quantity. If the monopolist reduces the quantity further, then it will have to lower the price. So the price is going to have to lower by the area here because there's a reduction in the willingness to pay of consumer L for this many units compared to this many units. So there's a loss equal to this area from this small reduction in quantity. What is the gain? Well, now the monopolist is going to be able to increase the price in the pair meant for consumer H. And the increase is going to be equal to this area here. So just as on the other diagram, it's this area between the two quantities and between the two demand curves. So the red outlined area is going to be a marginal gain from this marginal reduction in quantity, and the blue area is a marginal loss. And in this diagram, the gain is still much larger than the loss, so this is going to increase profit. We can keep doing this and keep increasing the profit. Eventually though, the marginal gain and the marginal loss are going to be equal, and that's where we should stop. So here we have the optimal price quantity menu. The optimal quantity for consumer L is QL star, and the optimal quantity for consumer H is still Q0H. We've adjusted the prices so that consumer L gets 0 surplus, their price is A star, their willingness to pay, and consumer H gets a positive surplus. We need to give them a positive surplus so that they won't want to buy the other option, because that's always going to give a positive surplus, and here the positive surplus is B star. So consumer H gets a positive surplus from this option of B star. It's the difference between what they pay and the area under the demand curve, which is A star plus B star plus C star. Now why is this the optimal menu? Well, let's think about that last small reduction in quantity. The loss, remember, is the area under L's demand curve between the old and the new quantity. So we've got the small change in quantity because we have to reduce the price in the pair meant for L by that area. The gain is going to be the area between the two demand curves and those two quantities. The gain is this red outlined area. So this is a gain because the monopolist is able to increase the price in the pair meant for consumer H. And in this diagram we can see those two areas are equal, and therefore the marginal loss and the marginal gain are equal. We don't want to go any further because then the marginal gain will get smaller, the marginal loss will get bigger. So let's look at the properties of the optimal price quantity pair. There's a downward distortion of the quantity for the low type. That is, the optimal quantity is less than the efficient quantity, or the quantity we would get under first degree price discrimination. There's no change in the quantity for the high type. We don't want to reduce that quantity because that just reduces the willingness to pay and the profit. The low type gets 0 surplus, so this is just the willingness to pay. Sorry, I've used slightly different notation here. This is the willingness to pay of consumer L for QL, where QL is this quantity here. The high type gets a positive surplus. We have to give them a positive surplus so that they won't want to buy the pair meant for L. So this is why we can't do as well under second degree price discrimination as under first degree price discrimination. The monopolist has to give up some surplus to the high type consumer in order to get them to buy a different pair than the other type. So profit is lower than under perfect price discrimination because H gets some surplus and the monopolist has to distort this quantity downwards. So it's selling less to type L.